All right, guys. Like I said, I was going to make a video for you over this worksheet, and Natalie reminded me because her note says, Mr. C, make a video over this 020917 Natalie. What? All right, so here's my graph. Again, let's put little arrows on here. They go on forever. Domain, I told you 100 million times, it's all real numbers. Range, look down, then up. First number I hit is that vertex, and that is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so that's 9 down. And what is that? 1, 2 over. So there's my vertex. So my range is going to be 9, including going all the way up to infinity. Vertex is 2, 9. We already just figured that out. Axis of symmetry would be x, and we pull out the x from the vertex, so x equals 2, and that'll go right down the middle if you wanted to graph it. All right, x-intercepts where it crosses the x-axis. I'll make those red so you can see them. That's right, cheer and cheer. So that would be -1, 0, and 1, 2, 3, 4, 5. 5, 0. Y-intercept where it crosses the y-axis. That's right, cheer. And that is 1, 2, 3, 4, 5. -5. Well, that needs to be 0 because that's x. -5. Increasing, remember that's when the truck is going uphill. And that would be right here. In the valley, the truck will start to go uphill right there. Remember, it needs to be x values. So from the 2 to infinity, it's increasing. Decreasing will obviously be the opposite direction. This is when it's decreasing, going down. So that would be -infinity to 2. Remember, you're reading this intervals of increasing and decreasing from left to right. Extrema would be max or min. In this case, since it's a valley, it's a min, and that skeeter is at the vertex, like it always will be, since it's a quadratic function. In behavior, as x is approaching infinity, the f of x is approaching infinity, or increasing, like we talked about in class. And since that one's infinity, so is this one because it's opening up. It too is increasing. Okay? And like we said, that infinity means it's increasing. Negative infinity means it's decreasing. Okay? Let's move on. Again, I'm not even looking at the graph. The domain will be all real numbers. Whoopsie daisies. It will be all real numbers again. Range, bottom to the top. That's -infinity to 0. Our vertex is going to be 1, 2, 3, 3, 0. Axis of symmetry, again, will be x equals 3. I'm pulling that from the x part of the vertex. X-intercepts, it's touching it once, so just 3, 0. Y-intercept, I'm thinking right here. That happens to be 1, 2, 3, 4, 5, 6, 7, 8, 9. 0, -9. Increasing, it's going uphill right here. So that's -infinity to 1, 2, 3. Decreasing, well, it's this side. So 3 to infinity. And remember, these are x values, reading left to right. Extrema, again, was that max or min. This is a mountain, so we're looking at the max. And remember, that's the vertex, 3, 0. In behavior, again, as x is increasing or heading to infinity, the y is decreasing. So -infinity or decreasing. And if that's -infinity, so will this one be. -infinity, decreasing. And again, -infinity means decreasing. I'm just going to start putting infinity, but again, I just want you to get the terminology down. Domain, no brainer at this point. It's all real numbers. Range, looking down, up. Since it's opening up, I know this will be infinity. But I need to count 1, 2, 3, 4, 5, 6, 7, 8, 9. So -9 to infinity. Whoops, that needs a bracket, guys, because the -9 is included. Excuse me, that was weird. X will be 0, -9, that's my vertex. Axis of symmetry will be x equals 0. X equals 0. Sorry, I was trying to get rid of that dot. X-intercepts, that'll be 1, 2, 3. 1, 2, 3. So we're looking at -3, 0, and 3, 0. Y-intercepts, that'd be the vertex, so 0, -9. Increasing, this is a valley, so this is when it increases, again, reading left to right like you're driving a truck. So 0 to infinity. Decreasing, we're coming from this direction, so -infinity to the 0. Extrema will be the min or max. This is a valley, so it's min, and then the vertex. And as x approaches infinity, y is infinity, and it'd be the same for this one as x is going to -infinity. Because remember, there's arrows on the skewer. Okay? Graph the quadratic function and write the characteristics. All right, so here's my slope, my vertex. Remember, pull out the opposite. Strange things happen in parentheses. So 3, -4. I'm going to go ahead and start that. Let's see, 3, -4. 1, 2, 3. 1, 2, 3, 4. I'm going to need a T-chart for this one, so that's just going to get in the way. Can I move all this? What? I'll put it right there. So 3, -4, 2, 1, 4, 5. I'm plugging in the 2. If I plug in the 2 right here, 2 minus 3 is -1. -1 squared is 1. 1 times 2 is 2. 2 minus 4 is -2. If I plug in a 1, 1 minus 3 is -2. -2 squared is 4. 4 times 2 is 8. 8 minus 4 is 4. Being it's a parabola, I know these will be mirroring the other points. So I'm going to come over here and plot them. 1, 4, 1, 4, 2, -2, and that was 5, 4. So that's 5, that's 4. Here's my axis. I'll do it this way. Axis of symmetry. And my actual parabola. Pinky out when you're, oh my gosh. Let me try that again. All right, pinky out. Almost made it. Yeah, there we go. All right. Domain, no brainer. All real numbers. Range, look bottom to the top. -4, bracket to infinity because it's opening up. Axis of symmetry, x equals, not -4, it'd be 3. What am I doing? What am I doing? All right, zeros, remember, are solutions. So x equals, let's see, where are x-intercepts? Maybe if my lines were a little better, I could pick these out. No, I'm going to figure this out the other way. Let's see here. We're going to have to go 2, x minus 3, squared minus 4. Making it equal 0, and we're going to solve for x. So I'm going to take care of that 4, add 4 to both sides. 2x minus 3, all of that squared, divide by 2. Those 2's cancel, x minus 3 squared equals 2. Take the square root. Then we get x minus 3 equals plus minus 2, we'll square root. Add 3 to both sides. Bump down a little bit. x equals 3 plus minus root 2. Well, that does me no good as far as where it's at on the graph. So I'm getting my calculator, I'm punching 3 plus root 2, and I get 4.41 for one of them. And then the next one, I'm just going to go up and change that positive to a minus sign. And then I get 1.59. These are my two zeros. Okay? So 4.4, so that's right here. And then I'm going to put a little comma here. X equals a little semicolon. I think that's semicolon. Oh, 1.59. 1.59. Whew. Notice those are equal signs, okay? That's what the zeros are. Y-intercept, or crosses the y-axis. Oh my gosh. I don't even know that. Well, that's when x equals 0. So I'm going to come over here in my equation. 2, 0, minus 3 squared, and I'm just going to work it out. 2, negative 3 squared is 9. 4, 18 minus 4, 14. All right, 14, and remember the x needs to be 0. Skadoosh. Increasing, decreasing. Again, increasing because it's in the valley. So we're going to start at the vertex, which happens to be 3 to infinity. Obviously, the other side would be decreasing. Extrema would be a valley, so we're looking at a min. And it happens to be the coordinate of the vertex, so 3, negative 4. And then as x is approaching infinity, it's opening up, so these are both infinity. And guys, remember, all this work was because my graph was crappy. So I had to make y equals 0. Okay? And then I solved for x, because you know how to do that now. I got to this point, and I needed decimals. So I used my calculator to figure out the decimals. Those are my zeros, in case you forgot. Oh, cursive zeros. All right, I've seen better. And over here, remember, y-intercept would be when x is 0. So I plugged in 0 for x, solved it, and I found my y-intercept. Okay? Let's keep going. 5. Ooh, I hope 5 is the last one, because I got things to do. Nope, I got one more to go after that. All right. Domain, again, all real numbers, no brainer. But now we're looking at well, it's not in vertex form, is it? We need to figure out some coordinates and to plot this thing. Now, I'm eating some jerky, so excuse me. I'm going to pick some random points right now because I haven't taught y'all how to find a vertex in standard form. So, I'm going to plug in 0 and see what we get. 0, 0, 3. Okay? Negative 1. Negative 1 squared is 1. Plus 4. Because negative 4 and negative 1 make a positive 4. 3, 7, 8. Notice that I jumped up. Let's go to 1 and see what we get. I'll plug in 1 here. That's still a positive 1. 1 here would make that negative 4. 3. So negative 4 plus 3 is negative 1. Plus that 1. Now we have 0. I'm going to keep going that direction. Let's try 2. Plug in 2 here. I'll get 4. That'd be negative 8. Negative 4 times 2 is negative 8 plus 3. That's 7. Negative 8. That's negative 1. See how it's keep going lower and lower? Let's see what 3 does. And guys, I know a shortcut through this, but I'll show you the shortcut later. I just want y'all to start thinking about this stuff in your head. You know, like 3 squared should be 9. Negative 4 times 3 is negative 12. Throw in the 3 there. 9 and 12. Excuse me, 9 and 3 is 12. Minus 12. That would be 0. Oh, you see what's going on here? I bet your life on it that this next one is going to be 3. Okay? Guaranteed it. Let's check. If it's 3, then you'll see the pattern and you'll catch on to what I'm doing. So if I plug in that 4, 4 squared is 16. 4 negative 4 is negative 16. Plus 3, hello, I called it. You owe me 20 bucks. Okay? Expect it in full tomorrow. So evidently this 2, negative 1 must be my vertex, and you can start seeing the curve. Okay? So I'm going to go ahead and plot these things. Negative 1, 8, nope, can't fit it. 0, 3, right here. 1, 0, that's right here. 2, negative 1, right here. 3, 0, right here. And then 4, 3. Boom. You know, we could do something else with that. You know, we could figure out the x-intercepts because we could factor this thing. 3 on top, negative 4 on the bottom, negative 3, negative 1, x negative 3, x negative 1, x equals 3, x equals 1. These are supposed to give us zeros, and look over here. 1 gets us 0, 3 gets us 0. I'm doing this so I can show you the connection here, okay? So let's go back to what we're doing. Vertex, roots, same thing as solutions. We just solved them. We graphed it and factored it to find the roots. Range, look bottom to the top. So that would be negative 1 to infinity. Axis of symmetry would be the x equals 2. Y-intercepts are crosses the y-axis. I have that value because when x is 0, it gets 3. So half my work is done already for me. Increasing, again, it's in the valley, so it's going uphill right here. So that's going to be 2 to infinity. Decreasing, and that's the other direction, so negative infinity to 2. Extrema, it's a valley, so we're looking at a min, and just put down your vertex. In behavior, it's opening up, so these have to be infinity. I hope, and this is where I really hope, see this factoring, the table, the graph, the characteristics, all of it's related, and I hope you saw that with this one. Based on the fact that I factored it and found our zeros, because that's what the whole point of this factoring was for. Okay? And let's go to the last one, so because I got errands to run. Match the quadratic function f of x to the characteristics. All right? The interval of increase is negative infinity to negative 2. Increasing. Okay, this is increasing from negative infinity. That looks like a 2, so that might be a maybe. Let's see. This one's decreasing. This one's increasing from that, what is that, 2, 4, 2, 4, 6, 8. Who do we appreciate? Mr. C, Mr. C. Oh, okay, I'm sorry. That's not it. That's not right. This is increasing, but it's not from the infinity. And this 2 is increasing, but not from the infinity. Must be A. A is the best answer. Let me erase these so we can go back to our process of elimination. The range is negative 8, less than, greater to f of x, but again, that's the y. Remember, this whole thing is y from coordinate algebra, and is less than 8. So the range, negative 8 to infinity. Negative 8 to infinity. That sounds like it's opening upward. So that's, okay, they're all opening upward. Look at this one. This one's at negative 2. This is at negative 8. And this is at negative 2. This is at negative 8, so it must be C. Axis of symmetry is located at x equals 8. Oh my gosh, that's no brainer right there. It is. Right across the 8. Must be D. Oh, I'm not even connecting these. All right, here's A, that was C, this is D. Interval decrease negative infinity to negative 8. Well, that's right there. Wait a minute. Yeah, that's negative 8 right there. Negative 8. Can't see it. And that would be B. So that is all of them. All right, I'm done. See y'all tomorrow.